One of my intents with these quizzes now, I'm sure you've noticed that every day they're all over Regents questions, okay? You can tell by the font. And sometimes what I'm getting at is the material being taught on the quiz. And sometimes I want to get at test-taking skills. So in this particular problem, numbers 1 and 3 are more about test-taking skills than material skills. Now, you could get them right with material skills, and my hope is that everybody understands how to factor for number 1, and for number 2, or number 3, I'm sorry, there's really, there's a good way to do it that we haven't quite taught you yet that's material based. However, for both of those questions, there's a way to work backwards off the choices. And I wanted to make sure that whenever you look at a question, you learn the skill of looking backwards from the choices. What I'm about to say does not apply to a kid who has gotten consistently, God bless, a kid who consistently gets, bless you, about 90 or higher, and on the Regents, they're shooting for that 85 or higher mark on the Regents. And by the way, I don't think I mentioned this to you, 6% of students statewide score a 85 or higher on the state test. 6%, okay? I just found that out about a week ago. Now, if you're one of the ones who's really looking for to be one of the 6%, this applies some to you, but not as much, because you're going to know so much material that you'll probably get it right just based on the material. But what about the kid who wants to get an 80? The kid who doesn't want to fail, which should never happen. That kid, there's, I think, like 28 part 1 questions or 27 part 1 questions. I would hope the first time you take the test and you go through the test that you would be able to say to yourself, man, I know how to do like 18 or so of these questions. Again, this is not for the kid who's going to get a really high grade. This is for the kid who's working hard to get through and wants to get an 80, a grade like that, which is still a very commendable grade on this test. So there's 27 questions, and they can do 2 out of every 3 just by looking at them. They know what to do. It's comfortable. They get 18 right. Now there's 9 left. If you can get half of those 9 right, you're going to get a really good grade on your test. The problem is if you get frustrated and you say to yourself, I can't do any of it. Well, do you know how, like, in social studies class, you take a test, and this used to happen to me so much in social studies. Let's say question 3 on the test was, in what month was the Battle of Gettysburg? And then a question later on, like question 21 would say, in July of 1863, Gettysburg took place. And you go, oh! And you could go back. You ever see that on tests? Yeah. Social studies and maybe even science a little bit? Well, you don't get that too much in math. But you can look at the choices and based on the choices work backwards. In other words, reverse engineer. How many people here believe in UFOs? Put your hand up if you believe in UFOs. All right. Personally, I have no idea. I'm not saying they don't exist, but I'm not sure that they do exist. Oh, well, actually, I do know for a fact that UFOs exist. That's a fact. I just don't know that they're alien. They could also be like our government coming up with these weird designs and test flying them, and they don't want the people to know about them. So anyway, we got these UFOs. The story is that the first one that they ever got a hold of crashed in Roswell. Have you ever heard of this? Oh, you need to look up Roswell on the internet. It's very suspicious, even if it's not an alien spacecraft. But supposedly an alien spacecraft crashed in the desert at Roswell. We got a hold of the spacecraft. It's in some bunker 50 million feet under the ground. And supposedly, here's the reason I brought it all up, we reverse engineered. In other words, we got a hold of what the answer should look like, and then we reversed backwards to do what we had to do to go forwards to design what they have. Supposedly Velcro came from Roswell. Supposedly the aliens had Velcro, and then we saw it and started to reverse engineer it. And all these other things about flight supposedly came from Roswell. And it is very coincidental that right after Roswell, we began to do things with aircraft that had never been done before. Like wildly better stuff, breaking the speed of sound, so on and so forth, ascending to heights that we could never have done before. Anyway, my point is we need to know how to reverse engineer a math question. And to reverse engineer a math question, let's take a look at number one. This is a great example. If you got number one wrong, maybe you got frustrated because you couldn't factor it. I'm going to go off to the side and show you how to factor it right now. Okay? First off, what do you do before you cross the road? Look both ways. So what do you do before you when you try to factor this? You look for a common factor. There is none. So I'm going to go to plan B. Multiply by 2, and I get x squared plus x minus 6. Then I'm going to factor that into x plus 3 times x minus 2. But since I multiplied by 2 here, I need to divide back in by 2, and I get 2x plus 3 times x minus 1. Now, my hope as a math teacher is that every single kid in the room looked at that, knew instantly what to do, and said to themselves, I got this. This is easy. And they went through and did it. But the truth of the matter is that that doesn't always work. And there are some people in here who really hate factoring. They shouldn't. It's very doable. It requires work, and it's work that they hate. Now, how else could you do this? How could you reverse engineer?
You take out the answer and multiply.
That's right.
That's what I did.
That's right. All you need to do is double distribute back and see which one, when you double distribute, gets you 2x squared plus x minus 3. Now the correct answer here is choice 4, so I'll show you that it works. 2x times x is 2x squared. 2x times negative 1 is minus 2x. 3 times x is plus 3x. 3 times negative 1 is minus 3. That gives me 2x squared plus x minus 3. So, here's my point. That is, by the way, the most difficult type of factoring that can possibly be given to you on your Regents exam. By far the most difficult type. So if you struggle with it, it's one of the most difficult topics on the test. And I'm sure when they put this on the Regents, they expected a lot of kids to get it wrong. What I want you to learn to do is reverse engineer the answers. Which ones, when you invert or reverse the engineering, gives you back the question you started with. It's a very important skill. I believe that if you got 18 right out of 27, and you learn how to reverse engineer, of those 9 that you would have gotten wrong, I think reverse engineering will get you anywhere from 3 to 6 of those 9 right. So let's call it 5. That doesn't add 10 points to your score. It adds like 16 points to your score because of the curve. So your grade could go from a 66 to an 82 because of your ability to get those things right. So you need to learn how to reverse engineer. Okay, the second question on today's work involved the graph of this. Now there's no way to reverse engineer. Actually, you know what? There is a way to reverse engineer this. You could have put them in on your calculator. Okay? I hope not. I hope you didn't do that. But if you did, good for you, James. All right? I hope that you realize this is the parent function, and that the 1 at the end, the plus 1, is what kind of shift? Loud. Vertical shift, so that moves it up 1. The 2 in the parentheses is horizontal, and it's always what in the parentheses? It's always reversed or opposite, so this was going to go 2 to the right, and the 3 in front makes it more narrow. So that gives you choice 2. It's narrower, which I don't even know if that's a word. The vertex is moved 2 to the right and up 1. So you could have reverse engineered that one as well. Now, another reverse engineering question, and we will get into a whole bunch of things like this maybe 2 or 3 weeks from now. I don't know exactly when, but we're going to cover these like crazy in what you call regressions. And we have linear regressions, Alex, and we have exponential regressions. We're going to regress questions like this like crazy in the future. And the best way to do it going forward is to do these regressions. But I haven't taught you how to do regressions yet. Yet I put this on the quiz. Why? Because you can reverse engineer this question. All you need to do is plug the coordinates in. This is the coordinate 0, 25. This is 2, 15, 60, 625. This is 4, blah, blah, blah. just plug them in and check. Is it pretty obvious it's not gonna be choice 3 or 4? Right? Is 25 times 4 9 million plus? No. Is 25 times 5 9 million plus? No. So by reverse engineering, that's out and that's out. Now the question is, which one of these two is it? God bless. So I would just take the 0 and plug it in. What's anything to the 0 power? 1. If you forgot that, they give you this giant cheating machine called a calculator. You type 25 to the 0. It'll tell you 1. If you do 25 to the 0, the calculator tells you 1. What does this tell you? 25. So now plug the 0 in here. 0 plus 1 is 1. 25 to the 1 is 25. So now you should be saying, that could be it. Let me check another one. Let's go over to 4. Let's do 25 to the 5, and it would come out to that big, long, ugly million number. And that would be your correct answer. So, rather than get discouraged when you don't immediately see the answer to a question on a quiz, or on your Regents exam, or on a test, you are to reverse engineer it. Okay? Once you reverse engineer it, you're in good shape. All right. So, let us put this away and let's get started on today's sheet. All right, a radioactive substance decreases. And I want you to notice how the quizzes and the do it and everything flows together. These do it quiz questions were all about reverse engineering and learning how to get questions right on a test when we're not exactly sure about the material in the question. And we worked a little on something from a week and a half ago with the vertical, horizontal shift, etc. And now this is from the last couple of days. I don't want to put this on a quiz yet, because I don't think we've done enough of it that you're going to get it right. But next week, definitely fair game. Radioactive substances decrease in the amount of grams by 1/3 each year. Starting amount is 1452. Write a recursive formula. I am so thankful that this is on here, because yesterday I had a brain cramp and I wrote an explicit formula. So I actually recorded the second classes so I could put the recursive formula rather than this. The recursive formula is a sub n plus 1 is going to equal, what's the ratio here? It's 2/3. So it's going to be 2/3 times the previous term. You could also write it like this. In fact, I usually write it like this. The new term, a sub n plus 1, I know we say a sub n plus 1, I hope you understand that means the new term is 2/3 of the previous term. That's your recursive form. Yesterday I wrote the explicit form, and I should not have done that. Now, let's take a look at, oh, I'm going a little fast here. Any question about this? Okay. Exercise 2, a rare coin appreciates at a rate of 5.2% a year. Appreciates. Do you think that means increases or decreases? Increase, definitely. Depreciates, it would be decrease. If the initial value is 500, after how many years will its value hit the $3,000 mark? Let's show you 2 ways to do this. Ready? A little bit of test wiseness, sticking with the theme for the day. The amount in the account is going to be the initial amount, 500 times. Now this is going to be 1 plus, agree? Because we're increasing, you just told me that a minute ago. You with me here? Remember, it's always 1 plus in the parentheses. This would be 1 plus 5.2%, but we write 5.2% as a decimal. So it's 1.052. 2, check this out. This is slick. This is so slick. How many people looked at this and weren't exactly sure what to do?
Question mark.
Tell the truth. I think most of you. Okay. So let's put X here or T. Okay. Do me a favor. Put that in your calculator as a graph. Oh, this is going to be so slick. You're going to love this.
I hate when Dad says that. He's like, oh, that was so slick, and I'm like,
This is slick. I'm going to show you the blood and guts way, then I'm going to show you the slick way. Okay? Blood and guts way, go to table, and find when the Y is 3,000.
nothing's happening. I don't see no graph.
It's too high up.
Yeah, don't worry about that. Go to table. That's why I said table.
Am I supposed to go up or down? Because I'm going all the way up.
You got to keep going up. You're going to have to get to a significant amount of time.
Wait, were you?
If I had to, hold on, let me just do this, 14, 7, 14.
Wait, we're
I think you're going to have to be at about 21 for the X. 36 is you got to be that high? At 36 for the x, what's the y? I'm sorry, let me hear James. What was that? All right, so at 36 years, it would be 3,000 plus. Okay? So that's one way to do it. Does that make sense, everybody? In other words, the y is the output, the x is the input. So I just go to the table, and I keep looking at the table until I see a number bigger than 3,000. So here was this really difficult question that we're able to do. But this is slick. You ready for the slick one? Everybody kind of get your hands tingling, because this is going to be slick. This is slick. This is really slick. Okay? Do you remember, hey, remember how when we would graph like one line and we would graph another line and the point of intersection was the point that satisfied both? Okay, now go to y2 on your graph and type in y equals 3,000. Okay? Now, with y equaling 3,000, one of the lines is going to be the 3,000 line, the other one is going to be this particular exponential graph. Now the problem is, as somebody mentioned before, it doesn't appear in the window. So let's play with the window a little bit. We already know the answer is going to be 36. So let's put the x minimum, 0, the x maximum, let's go 45. And we already know that the y has to be 3,000, so let's go a little bit above 3,000. Do y minimum 0, y maximum 4,000. And then hit graph. Okay. Yeah.
What you say to do?
All right. I said to myself, I'm losing them, so I just started my own computer or calculator so that you can see what I do on my calculator. First, they're going to make sure I have a license for this thing.
This is obviously illegal in the United States. 35.
God bless. Okay. Ivy, I think you're doing it perfectly. Thank you. Thank you. Thank you. Okay, so let's go to y equals. And the first thing that we plotted in there is 500 times 1.052, right? And that's going to be to the x power. Then what I said, now, if let's just, and let me go to window. All right, window. And I'm going to go x minimum 0, x maximum, and we're going to go to 40. 45, so be it. Okay. Now, y minimum, we're going to go from 0 to 4,000. And I'm going to hit graph. That's all right, don't worry about that. So that's my one graph. Now, this is a picture of this function. Now I'm going to do y equals 3,000. And when the y equals 3,000 line intersects that line, that's when this curve is what? 3,000. So let's go back to y equals and put 3,000. You could do this for any equation on the face of the earth. You could put in the top one, you could put 2x plus 10. And on the bottom one, you could put 7x minus 40. Graph them and see where they meet. And that will solve any equation you get on your entire test. Yes?
It's like really far away and we can't see it. How do we like find where
That's the next thing I'm going to get to. So let's go to graph. All right, look, I have the graph. There's a wonderful function on here called calculate. So I'm going to go to second calc, and you see the one that says intersect? Hit 5 for intersect. Now, there's a little blinking bug here. I like to get a little closer to the point of intersection. Okay, the little blinking bug, this is saying, is that blinking bug on the first curve? It is, so hit enter. Now it moves and it says, is this blinking bug on the second curve? Hit enter. Then it says guess. Whenever it says guess, just hit enter. And look what it says. It says the y is 3,000 when the x is 35.34. Now, do I give years in terms of decimals? No. It's either 35 years or it's 36 years. And the problem specifically said, when will he have 3,000? Does he have 3,000 at the start of the 35th year? No, but when you hit the 36th year, he has 3,000. So there's your answer. So from now on, let's just do this really quick. Ready? If I was to do, I'll just show you how you can use a calculator for this. Ready? If I was to solve this equation, 3x minus 1 equals x plus,
7.
hold it to, let's go with 3, because I want to keep the numbers small. First off, go to the y equals button on your calculator and clear them both out. Okay, now, in the first one, I want you to put 3x minus 1. In the second one, I want you to put x plus 3. Now, the next thing that I want you to do is hit graph, and they're not going to appear because your window's all screwed up, but go to zoom 6. Now, where do they cross? If you're not sure, go to second calc. What is it? Okay, I'm only solving for x, so what do you think the answer is? 2. Check it out. If I did it this way, minus x, I would get 2x minus 1 is 3, add 1, 2x is 4, divide by 2, x is 2. So now, any time you get any equation on the face of the earth, you can do it. For those who have struggled with quadratic equations, let's say I gave you 3x squared plus 7x equals x minus 4. You could put one of them as 3x squared plus 7x. The other one as x minus 4 and graph them. Now the trick is though, you know how with quadratic equations we get radicals in there sometimes? Right, like the quadratic formula? That won't show you a radical. So you still have to need to know how to do that. But if you're absolutely stuck, by putting in this as one y and this is the other y, it will tell you the x value. Which is really slick if they say round your answer up to the nearest tenth, because you can do that. Okay, so one of the big points today I wanted to mention was how to reverse engineer. One of the other big points I wanted to mention today was how to use the graphing calculator to solve equations. And please, 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 I know this is going to be tempting. Don't sit there and say to yourself, now I don't have to learn that stuff. I can just plug it into the calculator. That's the fallback if you don't know how to do it, okay? It's not the primary way of doing things. And then I wanted to review a little bit about these exponential functions and how to work them, which we just did. All right, so let's go out here and learn some new exponential growth kind of questions for today. Callie and Joe are examining the population data in the graphs below for a history report. Their comments are as listed. Callie, it looks like the U.S. population grew the same amount as the world population, but that can't be right, can it? Joe, well, I don't think they grew by the same amount, but they sure grew at about the same rate. Look at the slopes. Okay? Is Callie's observation correct? Why or why not? Who's got it?
Why do we need to know about population?
The question is not population, the question is reading graphs. Emma?
Why, one goes by 1,000, one goes by.
Yeah, look, this is 0, 50, 100, 150, 200, and this is into thousands. So this graph is actually far more condensed than it should be. If I spread this out by hundreds, it would look much more like a curve, okay? All right. Use the world population graph to estimate the percent of increase from 1950 to 200. So let's go to the world graph. Anybody remember how to do percent of increase or percent of decrease?
Nope.
That's something that you do a lot of in 7th grade. In fact, I tutor a 7th grader, and just last night we were doing percent of increase and percent of decrease problems. Does anybody remember the percent proportion? This is important. You should remember this. They will put some of these things on the regions, and we really don't talk about them. You're supposed to know them from the past. What was that, Ivy?
10?
No. Percent over 100 equals part over whole. Is that ringing a bell with anybody?
Yeah.
Should be. All right, percent over 100 equals part over whole. It wants to know what is the percent of increase or decrease, so it's n over 100 because they want to know the percent. Now the part is the amount of decrease or increase. So from 1950 to 2000, it's going from 2,500 to 6,000, which is an increase of 3,500. Out of the whole, which is the original amount. The original amount was 2,500. Die, cross multiply, 25n equals 3,500, which would be 35 times 4, which I think is going to be 140%. I'm pretty sure that's right. Can somebody do 3,500 divided by 25? I'm right? Okay. So it goes up by 140%. That's the percent of increase. Okay? Next up. Now use the U.S. population graph to do the percent of increase. So you guys do the same thing for the U.S. population graph.
Oh, thanks.
Percent over 100 equals part over whole. In this case, the part is always the amount of the increase or the decrease, and the whole is always the initial, original amount, not the biggest amount, the original amount. Sometimes it's the biggest, sometimes it's not. What's that? Okay. Let's use your numbers to help me do this a little bit quicker here. Again, percent over 100 equals part over whole. Percent over 100 is part over whole. I want to find the percent, so that's n. All right, how much did it go up? It went from 150 to what, about 275? So for argument's sake, that's 125. You may have had a slightly different number. Out of the 150. Cross multiplying, let's see, I can actually reduce this to 5, 6. I get 6n equals 500. What is n, like 83? What do you get? Is it 83.3 repeating?
Yeah.
That's what I thought. Okay, so 83.3 repeating percent. Okay, any questions?
I can't remember that.
All right, hold it. So here is the same world population graph, except this time we spread it out a little bit. Can you see the exponential nature of the graph now? Okay. All right, so what your job is to do is to take a look at the homework, keep working stuff out. Here's your exponential function, etc., etc., etc.